Hello everybody. Yeah, it's very nice being here. I I'm going to talk about the data governance, and I know it's a topic that like maybe is more like familiar to some of you, but maybe for some of you like you haven't thought about this before, especially like when you have been, kind of doing data project by yourself, and then maybe, oh, you haven't like came across all these like struggle before. So I'm going to share with you what I've experienced in the past, and how we're going to overcome that, hopefully. So here are all my contact details, so you can contact me, or if you have questions, like the organizer just said, that like you can post it in Slack, and hopefully I can answer it for you. So, right. I'm out of focus, but it's fine. So Zoom is very nice because you can kind of show your hands by not showing your hands. But anyway, if you have handled data at work before, maybe you can do the show hand things on Zoom. Or you can show your actual hands as well. I see a lot of waving hands, which is amazing. If you have handled data at work, maybe you would feel something similar to what I've experienced. That is a big struggle when you have people sending you data, you're asking people for data, you may have to change it yourself because, well, like all good data scientists, before you do any experiment, you want to do some feature engineering and clean up the data as well, because real world data is very messy. You end up something like this, right? This is fun. This is something I found on Twitter years ago that is already a thing that people are struggling because, well, we have some data coming in, we process them and then train them. It doesn't work so well. So I would fix it a little bit and train it again. Maybe I should change the model as well. And at the end of the day, you kind of actually I don't like the final version. May I go back to version 1? And then you're kind of like, okay, which one is version 1? Or you have like copy of things, which is amazing. Like, you can have long names, but you would basically at the end of the day you would scratch your head. It's like, oh, which one do I want? Managing the data and the model and all the all the data that you use for your experiment with like carrying out this amazing data science machine learning work can be quite troublesome. So I'm talking about my own experience because I am an ex-data scientist. I'm currently working for TerminusDB, but I used to work in data science. I love open source. That's why it kind of drew me away from doing actual data science work, but actually like having a look at the tool to see like what we can make, especially open source tool that can make the AI pipeline and machine learning work much better for data scientists. Also, I organize a lot of events, so if you're interested, you can talk to me as well. Also, I stream on Twitch sometimes, especially during the pandemic, not so much nowadays. But anyway, that's me. And so for me, I am a strong believer of I'm kind of a little bit of advocate for ML ops because just I've explained like all the struggle that I had when I was working as a data scientist. And sometimes like, especially when you work in a data science team, a lot of times like you don't know where the data that is useful is coming from, right? It could be, I want to have a look at some data in some database, and before you can have access, maybe your client or your, the other part of the business, they will send you a sample, and then you have a look, and then you need to request the full access of the data and stuff, and then you have to do a lot of paperwork, talk to a lot of security people or people who manage the data, another team, lots of things so that you can get access to the data. And sometimes when you get the data, you don't know how to work with it because sometimes the explanation is not that clear. You don't understand the name. A lot of times, especially for legacy database, they would have shortened the names because, storing things used to be very expensive. Sometimes if you're lucky, you have someone who have been working in a company for a longer time, then you can ask, have you looked at that before? Do you know what they mean? And things like that. But if you're unlucky, you would have no one knows what's going on. People who used to work with those data would left the company a long time ago, or there's sometimes migration from legacy system to, the oldest legacy system to something that's already a legacy, and then, and then to the current system that you're using. So all these like piping data in and out could create error as well. So it's quite a big mess. We want to make it more streamlined, right? We want to make it less painful. So that's why nowadays people talk about ML ops, because, we have a DevOps, you may have heard the term. That's more for developers, like how they can streamline their work, how to make the code, very synchronized, or like how to make it better, or how to deploy the product without lots of bugs and stuff. So, yeah, so that's a big problem that software engineers are solving. But it's like starting to care in the machine learning kind of field. So we should look at it. So like I said, engineers, they already have this this mindset of, oh, we have problem here, because when application getting more and more complicated, you have to work together, right? You don't work by yourself, so if you're lucky, you may have like, oh, you can sit with your colleagues, and then you can just like kind of, if you have problem or if you don't understand things, you can just like, oh, walk over to their desk and talk to them. But if you are, for example, working in open source, especially, you may be working with strangers. And so that's why we need some really good way of communicating between people. So, well, you can think of like, oh, maybe we can just send emails around, right? Because like emails has been something that has been used since the early day of the internet, right? And then like people send email around. But the problem is that sending emails is just like text. It can be random. It could be you don't understand what it is. And so software engineers start to think about how we can make things more structured and make things more neat and tidy. And there's a standard process of doing it. So some of you may already heard about it. There's something amazing called Git. So it's basically Git is a name that happens in all the kind of software development 101 book nowadays, especially when you work in open source, you must learn how to use Git. So Git is actually when it started, because developers, when they start to early on in the like open source movement, people are kind of sending messages to each other because they're working with strangers. But so soon enough, they realized that, oh, actually, we have to have some protocol, some standard that when we send messages to each other to like tell them, oh, hey, I want to add this code to the code. Is it okay? So they created this to make things much easier. So there are few operations in Git that is very useful. So I want to introduce them to you. So they are making branches. So everybody can make a copy of, not exactly copies, but like, because, well, if I talk about Git, I can spend another hour talking about Git, right? But in Git, in a nutshell, things are happening, all the changes happen layer to layer, right? So it's instead of storing the current version, it will store the original version and then all the steps of changing it. So by making a branch, meaning that from this point on, I'm changing it in a way that, may be different from yours. So let's say today when we go to work and then we all make a different branch. So everybody start from the same point, but we all do different work. So we won't interfere with each other until maybe we decided to combine our work at the end of the work day, right? So it kind of branches allow people to work asynchronously. People can work, on different things. So you don't have to wait around or worry that when you combine them, things will get messy. Sometimes it will, you may have your work that is like interfering with each other. But if that happens, Git also provide very good stuff for you to see the difference. That's the diff that I'm going to talk about in a bit. Another thing that Git provide is rolling back, is that, like I said, because in Git, all the steps that you make changes are stored separately. So for example, you have done something this afternoon, but you realize that, oh, actually, I made a mistake. I want to go back to what it happened this morning, so I don't have to start from scratch again. I can kind of, it's like a fail safe. So you can actually go back to what happened before. This is extremely useful, especially working with data, because you can imagine you make experiments and all this stuff, and then sometimes, oh, it does not work. So if you have this rollback kind of mechanism, you can go back to what you have done all this experiment thing before, right? You go back to where it used to work. So that's a good thing. But I don't think there's a lot of people realize that they need that, and but they realize that they need that. But instead of using a tool, they may just make some copy of things. Again, like it will be copy of things, right? We don't like that. Another thing that I mentioned a little bit before is Diff, to compare the changes. So again, like, after you have done your work, your colleague have done your work, and then at the end of the day, you want to, put all your work back together, right? Because, well, when you release your product, you want all the work to be included. You don't want to be excluded, otherwise you have done work that is not useful. So when you compare the change, so Git, most of the time, if you don't interfere with each other, Git will be very smart, and then like, oh, we just, maybe show you what you have done to the changes, and then maybe your colleague will have a look, because they may have more experience, or maybe just an extra pair of eyes to check everything's okay, and then you can combine them. But if unfortunately your work kind of clashes with your colleague's work, you can also see what are your changes like in both ends. So you can kind of say, oh, actually, my work is not as good, or my work is not updated. So we can fix that. So at the end, that happen is the merge, when everything just combined together. So sometimes you have to solve merge conflict, which is what I just described, because the changes kind of interfere with each other. So there's a human intervention here to like decide which one we want to keep. So that's most of the useful thing that Git provided. Of course, there's other like more complicated operations, but we don't worry about that. So this fourth thing is the thing that I think is quite useful when we do data science work, because if we mess with the data, like I said, we can roll back, or if you kind of do some experiment with some part of the data and your colleague did some use, it's the same data set, but like you focus on this part of the data, or you just, for example, I'm NLP expert, I would do some kind of encoding for the text part, and then your colleague may be like, oh, building some other things to deal with some maybe building another neural network or something. Then like you can, you can both work differently, and then at the end you can combine the work stuff, which is good. So how can we do that? Can we just use Git? Like Git is so good, like it, developers are using it. Maybe we should just use it. Also, another thing that is make open source so powerful nowadays. Everybody's using open source tool. I'm sure that a lot of you are using open source tool, because data science world, we love open source tool. That's why we have pandas, we have NumPy, we have SciPy, all those stuff. So one thing that really power open source development is GitHub, which is a online version of Git that let people who can you can work with strangers very easily. You can send something we call pull request, which is like a message to whoever is in charge of the project. You can tell them, hey, I found a bug, I want to fix it. Is it okay? And then they can say yes or no, or ask you to make some changes until it got a okay. So yeah, so that's something that I think GitHub now is so popular. Every student will be encouraged to open a GitHub account. So I'm sure you're not unfamiliar with it. So again, go back to the question: can we just use Git? Right? Git is so good. Actually, there's some problem there. So I mentioned GitHub before. So GitHub, I think if you have some experience with it, and especially when you work with data, you may come across something that actually Git complaining that your file is too big. That's because data is different from code. So code is some text, right? And usually when developers create their project and create a code, they would not have a file that is super big and contains all the code in there, because it's just make developing very difficult. So so that's why GitHub make this assumption that, well, your file shouldn't be too big, right? Because otherwise, I don't know what it is. It may not be code. And GitHub is for open source, like for the source code. It's meant for code. It's not meant for source. Stalling a very big CSV, it doesn't like it. So it's a no-no. So for us, if we have data, especially a bigger data, of course, we don't want to store everything as CSVs. We want a database to properly store it. A lot of database out there, some of them relational database, it's just like a lot of tables that is combined together. Sometimes they're linked. Also, there are other not relational database. So for example, TerminusDB is not a relational database, it's a graph database. So instead of linking the tables, you have different objects and you link them together like a graph. But again, that's another talk, so I'm not going to dive very deep at the moment. So basically what we want is a database that we can store data, but we can also do the Git thing. So we want to use something that that basically is you can store data and you can do the revision control thing, the fourth thing that I just mentioned. So there are actually other things out there that can do that. For example, I think a more popular one will be DVZ. I'm sure some of you have heard about it, but DVZ is more like a relational database. We've got the Git function and stuff. There are also others that could also do, so TerminusDB is not the only one, disclaimer, so I'm not just kind of force you to use it, but I would demonstrate it with some like TerminusDB, because I'm very familiar with it, just to show you the idea. There will be also some code as well, because I write in Python. So for some of the operations is built with Python. So I'll show you a little bit of code and hopefully demonstrate a little bit of things as well. So in TerminusDB, we can do branches. So I can see if I can show you something. So this is the online version of TerminusDB. So let's go to one of the databases I've created before. Oh, my internet decided to got frozen. Hello, let me refresh this. Just 1 second. Yeah, because I'm running a lot of things, so sometimes it's not very happy. Anyway, so this is what it look like when you just log in. So Terminus X right now, you can sign up for free. Just have a play, just like anything. Like you can play around with it. So I have already done some kind of example before in the past. I'll just open this one, Netflix graph. So here you can see that we have different branches, right? So we can actually create some branches here. You can also do it in the code, but I'm just showing this because it's very convenient and it's more pretty because, yeah. So you can create other branch, you can name a branch, let me try to create a new branch. So in this new branch, you can also look at what is going on. So here, actually, these are commits. So these are the steps that I talk about, right? Git also have different commits. So it's working in a very similar way. This graph is generated with some code, so the messages are not very useful because they're all just like computer, like looping through a for loop or something. So it's all the same. But you can customize it. You can have your own message to say like, oh, what have you done with this? Maybe like, oh, I am trying to, let's say I clean up the data, cast something as numeric, something like that. Then you can write it in a message to say like, oh, what have I done with the data? So branches, you see I've created new branch. So if you mess with it, let's say you wrote back to some experiment, something, and then, oh, actually I don't need it, I want to go back to like what it was, then you can just delete this one. So you can create something that you can run experiment with it, mess with it, and at the end of the day, if you don't like it, you can delete it, which is good. So rollback. So like I said, you have different commits. So you can, let's say I want to go back to this one, right? So 2-step back. It will be better if the message is different. But so what it does is I can copy and then I can say like, oh, I want to reset to this one, right? So you can reset it. So yeah, it got reset. So it will go back. So it's not very apparent, right? Because they're all the same, but you can see, oh, yeah, something changes. Maybe I can go back to this one. So it's more easy to see. So I can reset and go back to here. I don't want the adding of the content. So I don't want the content. I just want the schema. So I deleted all the content basically. Now I'm going back. But, you know, oh, actually I should not, you know, roll back because now I lost all my data. You can just like, oh, delete it, right? It's just like, okay, I will delete it. It's fine. Nothing happened. No one know that I messed around with the data. You know, clear all the evidence, right? Yeah, this is what happened when you roll back and delete the branch. So this is something new that is Diff, and then after Diff, it comes with patches because Diff is comparing two branch, right? Or two things, basically, you can do anything. So you're comparing the difference, and then patch is just like, oh, that's the difference. And then you can apply it to the original object and it will create a new object, something like that. So it worked on a lot of things. So this thing now we have actually, oh, I've closed it before, but we have TerminusDB was the different patch API. So we do have, yeah, now we do have the public API. So so yeah, like you can use it with a public endpoint. So if you're let's say running some something like with internet connection, you can just connect to this one and run the diff. So I'm going to show you how to run the diff in a bit. So we have actually all the code, the tutorial is on our GitHub repo. We love GitHub. So it's just here. If you want the link, I can also share with you after. So basically you can compare stuff. Let's see if I can show you something. So here I actually have some script that I have written before. So this is actually the script here. They're just this one and this one. So so there's JavaScript. So I'm not showing JavaScript because I am using Python. So so yeah, you can just create this is the public endpoint, right? So you can just use it in your script. And so what it does is like you create two objects and then compare them. So this is using the TerminusDB object. So it's, you know, maybe you're not familiar with. So let's look at the JSON one. So this is a JSON object, right? So I'm sure if you work with data, you have seen the JSON format. So this is not something that you're not familiar with. In Python, is a dictionary. So it's very similar. So sometimes they are in, like I use them interchangeably because they are very, very similar. So you can compare these two. So see, like, well, it's very apparent right now because you can see, oh, the name has changed, right? But what if you have two very big JSON file, then it's more difficult to compare. Then you can just use this, right? You can just write a script, or if you have to do something with the JSON anyway, so you can just do it in the script and compare the difference, and then it will print it out for you. So let me run this, and then you will see what does it mean. So div demo. Right. So, what have I done? I don't know what have I done. Why is it complaining? So, wait a second. Let me do something. Yeah. Yeah, maybe I haven't updated. That's why it's not. Something is not updated. Sorry about that. Let's think of why is it happening? It was running before. Okay, let's try the other script to see if it works, and then yeah. So okay. It's so very strange. So this is another script. Unfortunately, I am kind of running short on time. Otherwise, I would try to fix it. Yeah, I swear that it works earlier today. I don't know what happened. I've just done something. I think it's something that's not updated or something. So you can see this is Mongo, and you can use it with MongoDB actually. So I've created this. It's just a There's just something that I mess around with. There's nothing important storing here. So you can also have the compare something in MongoDB, and then it should also work. So let me see. Okay, so let me go back here. I'll show you the source code, and then I'll see if I can solve the problem and show you the demo. So this is another script. Again, it's hosted on GitHub. You can have a look if you want to, or try it out yourself. So this is just using MongoDB, and then I can compare the different objects and then make changes. So it could be used, mix and match. You can mix and match things. You don't have to always use it with just TerminusDB, so which is something that's great. Yeah, so I guess you can try it yourself. Yeah, I can't show you at the moment, which is a shame. But anyway, let's wrap it up, and then I go back to my demo if I have time. So, so last thing, remember there's 4 things, right? We got carried away. But this last thing is the merge, which is not available in TerminusDB yet. But basically, we have all the building blocks because we have the diff and the patch. So merge is a little bit more complicated because if something kind of, like I said, clashes with each other, then some human intervention need to be done. So to make this process user-friendly, it kind of takes some work. So, but other thing you can do is to use rebase. Basically, is to just so this is someone's work. This is my work. I just and then attach it, something like that. So it's more straightforward, but if your work doesn't kind of interfere with each other, rebase would just work the same. So when is this going to be useful? I'm a big advocate for ML ops. So if you are working with data a lot of times, like please try to have a better governing system with your data rather than making a big mess, which is like a spaghetti noodles that tangle together. So please try to use it. I know it kind of takes some work to think about how to do it. Sometimes you may have to discuss it with your team, but it's always good to think about it, right? So I think that's the end of the slides. I will try to see if I can fix the tutorial. I really don't know what happened. I hope I have the new version of my, I hope I have a new version of my thing, but it's not, error is not available. Maybe I spelled it wrong. What is this complaining? Oh, maybe I'm using poetry on the other thing. Does it? No. Oh, okay. Pip store national. Yeah, let's see if it works. I need the newest version of it. Maybe I use a local thing. Yeah, sorry about the hiccup. And it was working earlier. I swear, I don't know why. It just does not like to work. Let me try that again. I hope it works. This one. Yep, I don't know what happened. Why is it like so weird? I may have to look at the source code. So, right, not this one. Here. Yeah, I'm running a little bit short of time, so really don't know what happened. I'm using this correctly. Sorry about that. I would investigate later. I don't know why it's doing something very, very weird for me at the moment, but yeah. So
don't worry about it. I think it's okay.
Yeah, sorry about that.